Hello everyone, welcome back to the channel. Today we're going to be building a project that I'm just going to call the Apple Catcher. It's a really simple kind of game concept that I had to do in one of my university programming classes, and I think I did it in high school as well, to be honest. It's a very simple kind of game. The control is going to be with the mouse. The player can just move the mouse back and forth to control the basket, which needs to catch falling apples. And if you miss too many apples, you lose. Every time you catch an apple, you get a score, and that's it. Perhaps other versions of the same game, you could have levels, and each level could have a different number of apples and a different speed, and you could still do the lives system, or just have like a minimum score to require you to be able to advance. Other things you could do for variations on this game, you can have items that are a power-up that maybe make the basket bigger or smaller. You can have it so that there are power-ups that freeze the basket for a second, or make it so that if there's something you can catch that'll make you lose apples. Who knows? For those reasons, this is why it's probably a good example of something to teach, because there's a lot of different directions you can go with it, and it's easy to change the basket and apple out for something else. But in our case, we're actually going to use some assets that looks like a basket and an apple. So we can see here my really amateur basket sprite that I've made, and then just some apples that I've ripped. I mean, like I did borrow the front of this basket. The front of the basket's real, but I had stuff in it, so then I had to like paint it out. I mean, this is rough, but it'll certainly do. I've got an atlas with 5 apples here. Each apple is 240 by 240, so later when we draw apples, we can have some different choices, and we can have all the apples look a little bit different. So this is going to be a bit of a shorter implementation, because the game, when I say it's simple, it is quite simple. We want to get the bare minimum going, and we'll save bells and whistles for a future video. So first things first, I do have a project here that I'm starting with that just has some very bare bones Raylib code. So just a few of the includes I like to use, some consts to set the window size, the familiar game state pattern, a float for when the game started and ended, and then I also have a game init and update draw frame. Then we have the usual main here. I set a random seed if we want to use the standard library random stuff, although somebody made a very good point in one of my comments to say that, hey, Raylib allows us to generate random values as well. Don't forget to use that. So we may not end up needing this after all. Then we have the usual init the game. We have a gameplay loop, and then we can make sure to close the window, return 0. So very simple main function. Game init sets the state to playing and sets the time game started to get time. And game end sets the state to end and sets the time game ended. This is important because in one of my previous videos, we forgot to set the time game ended, and we got kind of a funny error. I believe it was Tic-Tac-Toe had a funny error that saying that it was negative time that the match took. By the way, this function right here is missing a prototype at the top, so I'll just go ahead and add that. If you don't know what a function prototype is and you don't know why that's important, I do have a video now on this channel that does a language overview. It's about 50 minutes, but it just talks about the concepts of C. In our update draw frame, there's very little logic left. So if the game is over and we press R, we can restart, and then I have a generic if, whatever the win condition is, game end, which in this case, the game end is actually always going to be lose in our game because it's about how long can you go. And then we have just our draw loop here where we clear the background, we draw anything related to the game, and then we can have a case for the HUD when the game is done and when the game is not done. So the first thing that I'm going to want to do is just get all my textures loaded in because I don't want to forget about this. So I have an atlas from apples, and I also have the basket. By the way, there's not really any real reason that these need to be separate textures. There's no reason that I couldn't combine these two images into one atlas. But for simplicity, I have all the apples on one and then the basket on another. After we init the window, but before we init the game, we can take this opportunity to load our textures. By the way, I have the project stuff hidden just for the simplicity of keeping the video clean. But the reason I was able to get these exactly right is because I have this folder opened up and I was just copying from what's over here on the screen. I'm trying out a new convention as well here. Any global variables that have the lifetime scope of the entire project are going to be prefixed with an underscore. I think this will just be a good way to keep track of which ones are global variables and which ones are not. This kind of relates to my section in the C language overview video about coding conventions, specifically when it comes to naming variables. You can come up with whatever rules you want so long as you stick to them for the entire lifetime of the project. Global variables here are going to have the prefix of the underscore. These ones here don't, even though they're global variables, but they also have the const keyword. I'm going to show off the other const here. So there is the const keyword, which we can use to define constant values, but we can also use the define keyword to define preprocessor constants, which means that when we compile the program, it's going to populate this value through. So if I say just apple source width is 240, and I don't put a semicolon, I just write it like this, and I can do the same thing for the height, which is also 240, then what this is going to do is anywhere that we put this in the code before it compiles the program, because preprocessor directive is actually before it does the full compilation step, it's going to go through and replace, like pretty much find and replace this text with this text. So it's very much a literal, I'm going to replace that value across the board. So this is kind of the two ways that you can define a constant value. Like I had said in the language overview video, the const keyword is actually quite complicated and there's a lot of different issues you can have with it. So sometimes it's better to use this define. And actually, even Raylib uses this define quite a bit. Here's raywhite, which has a define statement. C literal, which again, kind of a crazy, there's a lot to unpack there. But raywhite is this color, which is just a little bit off white. It's -10 on the RGB. So you can use this define keyword as an alternative to the const keyword if you find that you're getting weird compiler errors or warnings when you try to use const in your program. It's especially good for something that isn't strictly typed. So I'm using it to describe an int literal. Whereas if I was trying to describe a special structure like vector2, that's when you need to use some of this weird syntax like they did for this color example. Now we're going to get started on building some of the actual game logic. So I know I'm going to need to create a struct for an apple. An apple is going to have a x position and a y position, but I guess we could just express that as a position, vector2. And I'm also going to give an apple a fall speed. So that's our struct for apples. Now I had another comment on the C language overview video, I believe it was, that asked about being able to create dynamic lists where we can add projectiles to the list at runtime. Something that I've heard is generally an acceptable pattern is to just create an array that has a fixed size and treat that fixed size as the maximum. So I'm going to define up here an apple max count, and I'm just going to make it 16. I don't see how there could ever be. In fact, let's make it 8. And then down here, I can create an apple array of size apple max count. And I'm allowed to put a variable here. Normally we can't because it's not actually a variable, it's a define. And the compiler knows, or the language interpreter knows when it's checking for errors in this file, that this is really the number 8. And that's why it says expands to 8 right here. So we create an array of apples, and we're going to go ahead and add another thing to this, which is just going to say active. And this basically just allows me to determine whether or not that entry of the array is a real apple. So my pattern is going to be that I have an array of apples called apples. It has a size, which in this case is 8. And there's going to be an apple in each spot. However, there's going to be a Boolean called active, which will indicate to us whether or not we should treat this entry as an actual entry of the array or as a blank space. And for that reason, I'm going to want to update the game init. So when we initialize the game, we want to make sure that for each entry of apples, we set all of the apples to inactive. We don't need to give the apples a real value because we're saying it as active as false. So whenever we interact with the apples array, we're always going to want to check if it's active first. And if it's not active, we're just going to move on. It might be helpful to create a few utility functions for this to make it easier to handle our weird array type. So I'm going to create these two new functions, unsetAppleAt and setAppleAt. For unsetAppleAt, all we need to do is access the global array and set active to false. For setAppleAt, we're going to want to do the same thing, but in reverse. We want to make sure that the active is set to true. And before that, I'm going to initialize their values to what the parameters specify. Now, it's just me working on the project. So I know that I'm going to make sure that I try to pass the correct I value to these functions. If I'm going to check if I is the appropriate value, make sure that it's in the bounds, I'm going to do it outside of these functions. But something that's not a terrible idea is to make sure that the index is safe. This if statement that I've added to the beginning of each function is going to make sure that if I is a value that I know for sure will cause an error, I'm just going to leave early. This technique is called an early out. In a void function, we don't need to include a return statement, so this is maybe not totally necessary, but I'm using an early out to basically say, in this case, the function won't happen. So these functions are going to help us to interact with our list without needing to worry about having to manage the active variable. And now I can replace this with just unset apple at. So now this loop in GameInit is even more simple. I'm iterating over all the possible slots and making sure that the apple at that value is unset. While we're working on utility functions, let's write another one. This is another utility function, and all it's going to do is iterate through the list of apples and draw them. Since I don't need to have access to any rotation or origin manipulation, draw texture rect should work perfectly for this. First I need the atlas, then I need a rectangle source, which I'm just going to write apple source rectangle. Then I need the position of the apple, which is going to be apples at I position, and a tint, which we'll just use white. Now an important thing is happening here. I'm iterating over all the apples and I'm drawing an apple at every position, but I need to make sure that I'm having an early out if the apple is not active. In this case, I don't want to use return because that's going to quit the whole function. And I don't want to use break because it's going to quit the whole loop. I want to use continue, which is going to skip forward to the next step. Now we've still got this red line here because I need to define this rectangle. And this is a chance for us to use that C literal that we saw earlier. So an apple source rectangle for now is just going to be 0, 0, apple source width, apple source height. One thing to keep in mind here is that this position value can't necessarily be trusted, as the player is going to expect the position of the value to be the center of the apple, and the way that this will draw now, the position is going to be treated as the top left of the apple. So this is actually a case where we can either offset the position so that the position represents the center of the apple, or we can use a Draw Texture Pro. I'm going to stick with offsetting the position because I think it's going to be easier. So here we create a new vector 2 called position, and we start off with it being the same position as the apple. And I'm just going to offset the x and y of the position by half of the width and height, respectively, of the size of the apple source. Keep in mind that nowhere here are we specifying a scale at which we're drawing the texture. We're drawing the texture exactly whatever size it originally was, which means we're going to want to use the source size. And of course, I'm going to want to remember to update this value. So this should allow us to draw our apples at whatever location they're at. Problem is, if I want to test this, I'm not going to see any apples. Even if I was to remember to call draw apples from the game loop, still no apples. But that's also a good thing because it means that our active thing is probably working, since the positions are going to be set to random garbage values. Let's add a function to spawn a new apple. First, we need to find a safe index that we can use to place our apple. Here I'm creating a new int called available index with a value of -1. I'm making sure to create this outside of the loop as I'm going to need it once the loop is done with. Next, I iterate over every spot in the apples list, and once I find an apple that is not active, I save the available index and I break. Down here, I'm going to want to double check that available index is not still -1. As in this case, this is a tremendous error. I'll just return in that case. Sorry, this needs to be if it is equal because I'm considering this the error case and I'm returning. At this point in the code, we now have a safe value in available index. It's going to be between 0 and apple max count, inclusive on the 0, and it's going to point to a spot on the list that's not being used by an apple that's already on the screen. I think since the apples are going to be falling, we already know what the initial Y value is going to be of the position. It's going to be just above the top of the screen. But we do want to choose a random X value and a random fall speed. Now when it comes to random, it's really important that we have bounds to our randomness, so let's define some of those now. Fall speed min and fall speed max are going to tell us how many pixels per second the fruit should be allowed to fall. This makes me realize that we don't want to use a float for fall speed. We want to use an int. I would rather store how fast it should move in pixels per second, and then we're going to use get frame time to be able to scale it based on the user's frame rate. Back down in spawn apple, we're going to use our new defines to decide what the fall speed of the apple should be. Get random value is going to be the trick here. We give an int min and an int max, and it's going to spit out the value for us. And this will be easy. Since I've already decided on what those values should be, this is no problem. Once we have our fall speed, we just need to decide on a x position as well. Now the x position, we're going to use get random value as well, but we want to give some very specific parameters. We're going to want to use the apple source width by 2 as the minimum value, and the screen width minus the apple source width by 2 as the maximum value. This will guarantee that the entire apple is on the screen. Once we have our fall speed and our position x, we should be able to just set the apple at our available index to have a position of position x and negative apple source height, so that the full apple is above the screen and a little bit extra, and a fall speed as we found already. Now, we're not quite ready to test, as we're not calling spawn apple anywhere, but also the apples won't fall yet. We need to be able to update the apples. I've made this update apples function, and we're going to iterate over the full list of apples, and for every apple that is currently active, we're going to add to the y component of the position the appropriate amount. I'm going to borrow this loop since we're using the exact same format. We need an offset value, which is going to be the apple's fall speed times get frame time. Get frame time is going to return a float, which represents what fraction of a second this frame took to render. But the point is, this is kind of like using some kind of delta time value, where if the game is running very slowly, things won't happen more slowly. And if the game is running very fast, things won't happen more quickly. This is one way that we can make our games frame rate independent so that on different types of hardware, players will have a similar experience. Obviously, if they're having a lot of lag, they're still going to have a lot of lag, but at least this way it won't literally break the game logic. Once we have our offset, all we need to do is access the y component of the apple's position and increase it by the offset. If we do this for every active apple, we should see them fall. Now, for the purposes of testing, I'm going to make it so that when I click the left mouse button, we spawn an apple. And of course, we're going to want to make sure to call update apples before we start the draw loop. Let's cross our fingers and hope that we see some apples. Okay, there's our apples, but they're falling a lot more slowly than I was hoping. Maybe 10 to 50 isn't really the speed we were hoping for. Also, these apples are huge, so I'm going to want to adjust some things. I'm going to make them about a quarter of what they used to be. I'm also going to want to make sure to scale down the basket while I'm here. I also want to update this value up here, which spells out the source width and height of the apples. Okay, that's much better. Let's consider 50 the slowest and 250 the fastest. Now I'm going to spawn a handful of apples and we'll see how that looks. Now notice if I spam click as fast as I can here, it's not going to be the case that we're going to see a bunch more apples happening because we've already spawned 8 apples and we have nowhere in our logic to remove apples once they've fallen below the screen. So in update apples, we're going to want to check the position. If an apple's Y position is greater than the screen height, then we could say that the apple has been ruined. So I'm going to unset the apple at that value and we're going to continue. We're also probably going to want to, at some point, deduct score or deduct lives. At least this way, when I'm just testing, I'll be able to keep spawning apples. So I'm going to spam as fast as I can. I'm not spawning any more because we have all of them already. But now that some are popping away, I should be able to spawn some more. So we've got apples spawning. We've got them destroying once they've fallen too far. I'm actually going to make the screen height plus the source height by 2. That way we don't see them popping out once the center reaches the bottom of the screen. Before we start adding any more game logic, I'm going to want to get the basket drawing at the mouse position locked near the bottom of the screen, and I'm going to want to get the apple collision working so that the other way we can unset an apple is by actually catching it in the basket. So to draw the basket, we'll make another method, although it's actually even simpler. The position of the basket is actually going to be kind of predetermined. The X position, we're going to get the mouse position and use the X value. But the Y position, we're going to use a fixed value, something like screen height minus, let's say 192. And we'll have to see how that looks after, but that's our position. Next, we're going to want to offset the X and the Y by half the size of the basket. However, unlike with the apple where we had to use a define that said how big the apples were, we can actually just use the width of the atlas and the height of the atlas, since the basket is the only item inside the atlas. And lastly, it's the same as before. We're going to draw texture rect. We're going to use the atlas basket. And I'm going to do the same thing with the source rectangle as I did with the apple. I guess it's kind of bad practice to only define parts of it. So I'm going to go ahead and define the basket source width and source height. It's bad practice because using magic numbers in your program, meaning constant values that are just values, literals, instead of having a name attached to them in the case of defines and consts, can lead to a lot of confusion when somebody else looks at the source code. And even when we talk about somebody else looking at the source code, that also includes you later, because you're not going to remember everything from when you first implemented it. So here when I was doing this, width by 2, we can use, now I'm just going to update those values here. Here I'm just doing the height times 1.5 because I think 192 was about that value. I was just trying to put it so that it's a little bit higher than being right up against the bottom. This is actually better because now I can adjust this to like 1.25 or whatever, depending on how we think it looks. Oh, I forgot to update this. It's really important not to forget to call these functions when you write them. Okay, well now that we're seeing it in action, You may not agree, but I'll just tell you right now, this basket is way too high. This is kind of the value that I was expecting before. So now the basket's at a good height. We can see that as we move our mouse left to right, the center of the basket is always where my mouse is. And everything's working pretty good there. Now we're going to need this position value in the update function as well when we're actually checking the collision of the apples. So maybe it's better that we have this be the return value of a function. Okay. Now we're just going to want to make sure that when we set this position, we're grabbing it from get basket position. And then we just need to offset it and draw, and everything else should work good there. But now get basket position is kind of like we've parameterized it. So now when we're updating the apples, we'll be able to check collision with this and unset the apples accordingly. So in update apples, once we've passed the bottom of the screen check, we're going to try another check where we're going to see if the X value of the basket and the X value of the apples are close enough. So first I'm going to grab the basket position here, and I'm going to see if the absolute value of the apple's X position minus the basket's X position is less than the width of the basket itself. Now, this absolute value here is from the standard library.h header, but the parameters that we're sending in are floats, so we need to actually put abs f. Sorry, we need to use fabs. So what is fabs? Is that a thing? It's also a thing. Okay, so we're just finding out by doing the absolute value of one value minus another, you're finding out the distance between those two values. So I want to find out if the horizontal distance is appropriate. And if the horizontal distance is right, now I need to do the same thing, but for the vertical distance. Now I realize that I think I'm going to want to make these by 2, divide by 2, just to make the basket, because the basket has a width of 128, so the apple needs to be within 64 pixels of the center of the basket. So I want to make sure that I divide that by 2 for both the width and the height. Be really careful when you're copying stuff. I just realized that I spelled this function wrong, even though it's right above it. So in the case where the X and Y values are close enough, that tells us that the apple is colliding with the basket. And now we just need to unset the apple at that value. And we're going to want to increment the score. Again, we'll get to that when we get to that. Now at this point, we can continue because if we've unset the apple, we don't actually need to update the value of the position anymore since it's no longer really in the list. Here we go. And we're catching the apples. Great. Now that must have been 50. That was very slow. We're going to have to crank that up some more. The game's not really going to be that much fun either way. It's always going to be very easy. The only way you can make it hard is by making these values very high, and then it's so hard to where it's not even really clever. But we want to make it so that when we're testing, it doesn't actually take forever. If you want to make the collision a little bit more tight, you can basically just increase this denominator here, and that's going to make this value smaller, and then the basket and the apple need to be even closer. I think the width is okay, but the height could probably have used a different value. The thing is, we're drawing the apples before we draw the basket, and that's kind of affecting how this looks. So I'm going to go ahead and draw the basket before the apples. That way we can see the apples a little better. So yeah, you can kind of catch them with the side of the basket. I don't really think that's a bad thing. I like that. Because then really that means that if you're really quick, you could just kind of go like this. And you're free to do that if that's how you like to enjoy games, is by cheesing them. So now we really just need to add the game logic. We need to make it so that we have a certain number of lives. We need to make it so that we count how many apples the player is catching. And we need to make it so that the apples automatically spawn. So I'm going to add over here a float, which is next apple timer. And we're going to make it define time between apples, which I'm going to make 1 second. When we initialize the game, we want to set the time between apples, or the next apple timer, to be the time between apples. In the game's update loop, right in here when I update the apples, I want to reduce the next apple timer by frame time. If the next apple timer is less than 0 at this point, we want to set the next apple timer back to the time between apples, and we want to spawn an apple. I'm also going to go ahead and get rid of this debug method that spawns the apples manually. So this little pattern here of having the timer be reduced, when it hits 0, we reset it and we trigger something. This allows us to have something happen continuously. So now every second, a new apple should spawn. They're all going to have different speeds. Now after this timer, I'm also going to add an int, which is our score, and an int, which is our lives. When we initialize the game, I'm going to set our lives to 3. And I'm going to set our score to 0. Now setting it to a magic value is not really the best, so we're going to say initial lives Now we're going to want to find all the places that we unset the apple. Here when I say deduct lives, I'm going to say lives minus minus, and if lives is less than or equal to 0, then we're going to say game end. And in that case, we will return. And in the case where we don't return, we will continue to the next apple. At the next one here, we want to actually increment the score. So we're just going to go to score plus equals score per apple. And one more time, we'll just make the score 100. So now every time we unset an apple, we're making sure to change some value. This is all great, but we have no way to see any of these values happening. And also, our game logic is always going to happen whether or not we're playing. So update apples, apple timer, these things right here should really be in an if statement. We only want to update the apples and advance the timer if the game is running. Now, maybe you would prefer to still update the apples and have the timer running even when you lose so that the apples continue to fall and it says game over. But in our case, I think it would be better if the game just kind of froze in place. Now, here's the thing. Here we have state end and here we have state playing. So I would generally refactor something like this to be as such. So we have end and playing, and these are the two values. So we could have a switch, or I'm happy with just an if statement. So if the state is end, and then in here, we'll put this other statement and say game in it. Now, in the case where the state is not end, it must be playing. And then we can have that logic here. So this is the reset game check. And this is really just the update. Is this if and else. Because there's no, at least at this time, there's no code that we want to have in both the game over and the game running case. Now, for the game time HUD, we're just going to quickly draw some text. I'm going to use the text format method here. Basically, I can pass in a format string and then a list of parameters, and it's going to format that string for us the same way printf would. So in this case, I'm going to write score, %d, and that'll allow me to put in a integer, which is going to be score. And we can do the same thing for lives. There's our score text and our live text. Now we can draw each one. Score text at 0, 0, font size of 32, and make it black. And we'll do the same thing with the lives text. And we'll actually make the text smaller. So we'll make this one 48 and then this one 24, and we'll do like a dark gray. I think that'll look pretty cool. All right, let's take a look. Let's try missing some apples. And we can see the lives go down. And when it all goes down, the HUD disappears and the game freezes because we still haven't put in the game over HUD. Okay, just going to make some small adjustments to the position of these things here. I'm also going to want to nudge them a little bit away from the edge of the screen. Now here I am using magic values. I don't feel as though that's really necessary to avoid in this case because it's really just for the positioning of the UI. There we go. So there's our score and our lives. That all looks pretty good. Now for the game over HUD. For the game over box, I'm going to steal some code from the Tic-Tac-Toe. Yeah, so we're drawing this like faded thing and then measuring the text so we can center it. Okay. Okay, let's see how that looks. Okay, so we can still move the basket. That's one thing that we're going to want to change. There's the time played. And here's the thing, the score is missing from the screen. Kind of forgot that this game has a score. So I'm going to steal the score text and keep the formatting the way it is. So we have the score text, text format, except the position. We're just going to want to change this here. See how that looks. Okay, I think for some reason I can't get this to work properly, so I'm just going to give it the original position. And so what'll happen is when we lose, the score just won't change. The lives will go away and it will say game over and we can still see the score. There we go. So let's just fix the basket and keep it from moving once we lose. We're going to have this float, which is the basket X position. When we get the basket position, we're going to set the basket X position to this value, but only if the game state allows it. So we always return the position, but we only update the basket X position when the game is playing. So you can see now I'm waving my mouse and nothing's changing. Okay, so at this point, we have everything that is basically the bare minimum for this game. I guess we could have skipped having the atlases and just used colored squares from the beginning. But in just under 300 lines, we have this game. All the core features are fully implemented. I'd like to revisit this code in an upcoming video to add some minor polish to it. So we want to randomize the apple sprite for each apple that spawns. We want to make it so that apples fall faster the longer the game has gone on. Set up some kind of progression curve so that depending on our score, the range of apple speed that we're going to give to the projectiles will actually change. Also, something that I keep saying that you can do at home, adding sound effects. We'll actually go over that since I've talked a lot about it, but I don't think I've shown it in any of my demos yet. Maybe I did it in Minesweeper. I can't remember. Hopefully you've enjoyed this video. This is another Raylib demo in the books. If you're watching this video because you're taking a class in which you had to do an assignment like this, I'm sure you're not working in Raylib, so let me know down in the comments what you are using to build this kind of assignment. As always, there's a link to the GitHub repo in the description if you wanted to go ahead and clone this and throw in your own assets, try and make some of the changes that I've already discussed are going to be in the upcoming video. Maybe draw a nice, pretty scenic background and throw it down. Something else that could happen, and I've included the resources in this project for it, is I have a separate image of the back of the basket and the front of the basket. So if you draw the back of the basket, then the apples, and then the front of the basket, it'll actually look like the apple is falling into the basket. Usually you would use a mask for this, and those resources are included as well, but using masks in Raylib is actually very complicated compared to how simple it can be in something like Unity. So feel free to try it, but it's not easy. I've never asked this one before. If you like it, you should like the video. And if you want to see more, you should subscribe. I'm going to try to get into a rhythm of usual Raylib demos and C language tutorials intertwined. Thanks so much for watching, and we'll see you next week for the next one.